grand unification epoch. So it follows the Planck epoch lasting until 10 raised to the power of minus 36 seconds. Forces like gravity and the other three fundamental forces are unified as the universe cools, symmetry breaking leading to distant forces. So Saksham, do you know how this symmetry breaks? Hello Saksham. Okay. So Satyajit, what do you think about this symmetry breaking? And
Sorry, I was unavailable. Can you repeat that?
so how does the universe cooling lead to symmetry breaking? Do you know?
No, I don't have an idea.
Hyperthermodynamic states. Okay, I'm also new to this symmetry breaking things. But what I got, what my conclusion is that whenever like the universe cooled down, that led to material forming. Let's to understand it better, let's assume that we are on a desert, completely empty desert, and if we look anywhere, we can just rotate the whole universe, the whole desert, so that it was in the earlier stage. So that is called time translation symmetry. And if we look into any direction, we can just rotate it, the whole universe, the whole desert by that specific angle to get the same space place. But if we add a tree or something else, that symmetry breaks. So the time translation symmetry breaks and the rotational symmetry breaks. So our universe does not follow these uh, specific symmetries. So, and this has to do with the universe cooling. When the universe cooled, it also expand and there were material forming. So the rotational symmetry and the time translation symmetry broke at that specific point. So that is what I think. So, uh, do you have any questions about it? Okay, I think so. Victor has joined. So thank you, Victor, for joining us. So right now we are discussing about the Big Bang. Uh, we are just talking about epochs. These are times shortly after the Big Bang, and they are varied by different physical processes. So, Victor, if you have any questions, you can raise your hand and ask us. So, Gaurav and Saksham, did you understand how symmetry breaks? Hello, Saksham.
I had a question that you just said that when the universe cools, the it faster the expands gets.
Okay, so it's not like that. You can say that the cooling of the universe does not have to do anything with the expansion, but uh, like if the universe is cooler, it would expand faster. I'm not saying that it happened because of the expansion. The particles interacted less, and that's the reason the universe cooled down. So, did I answer that question correctly?
Yes.
So, did you understand the symmetry breaking stuff? Hello, Gaurav.
Not so well.
So, uh, like let's take a triangle. If we move that triangle by 60 degrees, it would be the same. So that is called the triangle symmetry. And if we take it to the whole universe's level, let's assume that we have an empty universe. If we throw a ball, what would what can we do? Like it travels some distance in a specific amount of time, and if we move the whole universe by that specific amount, the universe would be symmetric because there's nothing in the universe. It's empty, and we are taking in empty universe. So this is called the time translation symmetry. And if we have a metal rod and we move it by, let's say, 60 degrees, what would happen that we can just rotate the whole universe by that specific amount, and we'll get that same specific moment back. So that is called the symmetry break. Uh, the symmetry breaks because our universe is not empty. It has things in it. So did you get me, Gaurav?
Yes.
Okay. The inflammatory epoch. It occurs around 10 raised to the power of minus 32, 36 to 10 raised to the power of minus 32 seconds after the Big Bang. The universe undergoes exponential expansion, smoothing out irregularities. Evidence for inflammation in, uh, includes the uniformity of the CMB, cosmic microwave background. Yes. So Afia Roslin has said that, so firstly it expanded from a hot dense state and then symmetry breaks as it cools down, leading to material formation, right? So this is majorly it. So you are right. Evidence for cosmic inflation. The uniform temperatures of a CMB support the inflationary model. Quantum fluctuations during inflation speed, large scale structures, observations from all satellites like WMAP and Planck support this epoch. The electroweak epoch. So it starts from 10 raised to the power of minus 12 seconds after the Big Bang. The electromagnetic and weak nuclear force become distant. Particle physics experiments help us understand this epoch. So if you have joined our previous presentations, we were talking about the electroweak things, the quantum chromodynamics, and how the symmetry breaking uh, led to these two forces becoming distant, the electromagnetic and the weak nuclear force. Like at very high temperatures they can be unified. So but as the universe cooled, the electromagnetic and the weak nuclear force became distant, and the weak nuclear force bosons have mass to them uh, because I am forgetting the name, but it has to do something with the Higgs boson or something. The quark-gluon plasma epoch. So it occurs roughly between 10 raised to the power of minus 12 seconds to 10 raised to the power of minus 6 seconds. Quarks and gluons exist freely in a hot dense plasma. As the universe cools, quarks combine to form neutrons and protons. Nucleosynthesis epoch. It takes place within the first few minutes after the Big Bang. Light nuclei like hydrogen and helium and lithium are formed. Predictions from this epoch match observational primordial evidences. So, Saksham, you have raised your hand. What's your question?
Aryan, do you know that the what was the first element of the universe?
Okay, I think so. It should be deuterium.
No, first element.
A first element, hydrogen. These things should be the first, right?
No, Aryan, it was helium.
What?
Aryan, it was helium.
Okay. So I am still not getting how are we saying that the first element is helium. So can you explain your reasoning behind how helium was the first element?
That's because at that time the temperature was extremely high. At the first seconds of the universe, the first seconds to you can say 32,000 years, the temperature of the universe was roughly 9 to 10,000 kelvins. This led to the collision of the particles of the universe for the very first time, and this led to the formation of helium.
Okay. So someone is saying the first element is hydrogen. So like the first element that was formed in the universe was helium. He's saying suction. So that's a good reasoning. I think so. I read it
I will
somewhere.
just send it in the groups. That's how it was. I will send it.
Okay. The recombination epoch. Uh, it occurs around 3 lakh 80,000 years after the Big Bang. Electrons combined with nuclei to form neutral atoms. The universe becomes transparent, allowing photons to travel freely. So at this time, uh, the photons can travel freely. In the early universe, what happened that they used to get absorbed and uh, emitted, so they could now travel freely. Formation of the cosmic microwave background. So the CMB is the afterglow of recombination observed today has uniform radiation. It provides a snapshot of the universe at approximately 3 lakh 80,000 years old. Measurements of the CMB temperature fluctuations reveal early universe conditions. The Dark Ages, a period between recombination and the formation of the first stars. The universe was filled with neutral hydrogen and helium gas. No light was emitted during this time, hence the name Dark Ages. Epoch of pre-ionization. It occurred roughly between 400 million and a billion years after the Big Bang. First stars and galaxies form, emitting radiation and re-ionizes the universe. Re-ionization is studied through quasar observations and galaxy surveys. Formation of the first stars and galaxies. The first luminous objects formed from gas clouds collapsing under gravity. These objects initiated chemical reaction, enrichment, and structure formation. Observations with telescopes like Hubble provide evidence of early galaxies. Large scale structure formation. So, galaxy and clusters form from initial fluctuations. Dark matter plays a crucial role in scaffolding these structures. Simulations help us understand how cosmic web structures evolved. How do we know about these epochs? Observational data from the cosmic microwave background provide key insights. Spectrospec studies of distant galaxies reveal information about early epochs. Particle physics experiments simulate conditions of the early universe. Role of cosmological models. Models like the lambda CDM model predict the transition of cosmic epochs. They are tested under they are tested against observations to validate our understanding. Advances in computational simulations enhance our knowledge of epoch transitions. Summary of how we know the Big Bang. So, multiple lines of evidence, including cosmic microwave background radiation and galaxy redshift, support the Big Bang. The theory explains the universe's large scale structure and the element composition. Ongoing discoveries continue to strengthen our understanding of the universe's origin. Okay, so we are done with the presentation. So, do we have any questions? Hello, Saksham. Okay, Gaurav, you have questions. So, what's the question?
I had a question that what existed before the Big Bang?
Okay, so this is the exact question in this book. So it said, uh, okay, so this God thing, uh, okay, so let's not get to that topic. Uh, Before the Big Bang, there was nothing. It's like asking the south of south. So the south of south does not exist. So it's like asking that question. It's philosophical in a way. Uh, yes, it can be philosophical, but majorly people think that the universe came from quantum fluctuations. It was the starting of time, so we cannot ask what's before the starting of time. There was nothing. So did you get me?
So what was there, like a space or vacuum? What was there?
Zero by one. Okay. So like vacuum, like the vacuum of uh, it's a part of the universe. At that time, the universe did not exist, so there was nothing. There was no vacuum, no thing. Unless it exists. So, so did you get me? What am I saying?
Yes, yes,
Okay. So, Gaurav, did you like this presentation?
yes, very much.
So, what do you think? What should be our next presentation?
Maybe about how galaxies or stars are formed.
Okay, so okay. So, my father has sent an WhatsApp group invitation link, so you can join that. We do classes every Sunday, and there are also questions happening in the group. So, Gaurav, before that, your brother used to join. So, we used to discuss about the standard model of physics. So, my plan is we'll go from the Big Bang to the standard of model of physics again. But now we'll talk deeply about this. So, try to join every Sunday if whenever there's class. Yes. So it would be the same timing, 4 p.m. every Sunday. So I'm also connected with few more scientists. They do classes every Saturday. It's like in general question and answers. Your brother used to join, so there are questions.
But I had another question.
Okay, what's the question?
What caused the Big Bang to happen?
Okay, so what caused the Big Bang to happen? So people suggest it happened due to quantum fluctuations. So do you know what is an quantum fluctuation?
Not right now.
Okay, so okay, it's very hard to explain to you. So how will I explain it? So like there are things happening in nothing. So these quantum fluctuations are everywhere, and its effect can be seen in. There are many experiments that we have done and seen. So these quantum fluctuations are real. So these are fluctuations in space time. Like they can happen anywhere. They happen in your bathroom, the walls, in our cells also. So they are random bursts of energy, and these can happen anywhere. So it's like we got the whole universe for free. So did you get it? What is in quantum fluctuation?
Quantum fluctuation can happen literally anywhere, like
Yes,
vacuum or anywhere.
yes. So someone named as Mohanty has joined. So thank you, Mohanty, for joining us. So if you have any questions, you can raise your hand and ask us. So Afia Roslin is also there. So ma'am, can you introduce yourself? Sure. Okay, cost. Hello, Roslyn, are you here?
Hi. Yes.
So, ma'am, can you introduce yourself? I think so. You have joined for the first time.
Yeah, okay, go.
No, no, I was saying, can you introduce yourself? I think so. You have joined for the first time. Okay. I am Amira. So, ma'am, where have you joined from? I'm 26 and currently studying at a university from Malaysia and Singapore. So, ma'am, are you interested in science and what are you currently studying? Oh, I'm study mathematics, astronomy, and physics. Okay. So you have deep knowledge of this, right? Okay. Yeah. As well as economics and finance in Islamic systems. Okay, ma'am.
So, thank you so much for everyone joining us. And Gaurav, how was the class? You are studying fifth grade. I'm audible.
Your voice is cracking.
Okay, so actually, now I studied at fifth grade. He is much interested about the science and is connected with the
I
ISRO.
can't hear it properly.
Okay, this may be so. Aryan is much interested in science and maybe 8 years. And once again, I have joined another. Yes, my name is Naveen. I am the Aryan father. Right now, Aryan is much interested about science, and he's connect with the many scientists like the Bhava Atomic Center scientist as well as the ISRO scientists also. So, you have any suggestion for Aryan? Actually, he's very curious about the science, and also Victor is also know. So, Gaurav, what do you think about it too?
Yes, sir.
So you are studying fifth grade, na?
Yes, sir.
So actually, you have to join the Aryan WhatsApp group. Actually, Aryan is also sharing the information in the group about the science and as well as the poll question also.
Okay, sir. I will join it.
Okay, and and Victor is also know him, and some his name is Mohanty. So you are from, and can you introduce a little bit your side? So Aryan taking the classes in. I'm from the Odisha. Okay, he can engage in discussing countries. Uh, he can. Yes, Aryan is reading many books. So Aryan, you can talk with them, na? Ma'am is saying something. देखो, क्या देखो.
Can you type Naveen? I'm from. He can engage in discussions. Okay, ma'am. So I also have many a few books of Stephen Hawking's, and I think so. I also have a book of Michio Kaku. So I try to read them. I'm going for a revision now. So I have two books of Stephen Hawking's, the Theory of Everything and Brief Answers to Big Questions.
Hello, hello,
Hello, Victor.
hello. Yeah, good afternoon. Yeah. Actually, I want to suggest something.
Uh, uh,
Are you with me?
Hi, can
There is one particular, okay, there is one particular book that I read about. I think Yuval Noah Harari, when he talks about sapiens, when he talks about the evolution of human being, when we are going to evolve from Homo sapiens to
okay.
Homo
So,
deus.
which
Yes,
book
I
are you
don't know
talking
if
about?
Sapiens, the title of the book is Sapiens. The author is Yuval Noah Harari.
Okay, I don't think so. I've heard of that book. So, who,
Okay. I don't know if we can just if we can like go through it and discuss about it. I've already read it, but if we can just go through it and discuss about it, I'll be
okay,
very glad.
okay.
Thank
So,
you.
thank you. I think so. We should end the presentation meeting now. So, thank you everyone for joining. Okay, so if you have any questions, you can ask us right now too. I don't think so. Any questions?
No questions. So I'll be
Okay.
rounding up for now.
Okay. So thank you everyone for joining us, and bye.